Okay, today we are going to be talking about angle-pair relationships and how we identify them. So, just like when two lines intersect and form special pairs of angles, so those are the vertical angles and linear pairs. These are formed when two lines intersect. We can also have special angle relationships created when two lines are intersected by a transversal. And transversal is just a fancy way of saying it's a line that intersects other lines. So, one way that we can identify our angle relationships is where they are on our transversal. So you can think of this as a street. Transversal equals street. All of these angles right here are on the same side of the street as each other. But then over here, we have pairs that are on alternate sides of the street. They are on different sides of the street from each other. So you have to cross the street to get between them. The other way that we can name our angles is by, or our angle relationships, is by where they are in relation to the two lines. So you can think of these lines as the walls of a house. Whenever you have things that are inside the walls of the house, between those walls of the house, we call that the interior of the house. But then, if we have things that are on the outside of our walls of our house, we call that the exterior of the house. So if they're inside the lines, they're interior. If they're outside the lines, they're exterior. So, we name these angle relationships in a very easy to remember form. We name them by where they are on the transversal. That's our street. And where they are with respect to the two lines. Those are the walls of our house. So line L and line M are the walls of our house. And then line T is our street. Now, if you want to practice this on your own, there is an asterisk, so this is in your practice problems for today. Go ahead and pause the video and see if you can figure out the naming on your own. All right, so let's start with angle 3 and angle 6. So angle 3 is right here, and angle 6 is right here. So the first thing we need to ask is, where are they on the street? Well, so the pink line is our street. Angle 3 and angle 6 are both on the right side of the pink line. So they are on the same side. Now let's look where they are with the walls of our house. If we look at our dark blue lines, the walls of our house, 3 and 6 are both interior. They're inside, they are between those two walls of the house. So angle 3 and angle 6 are same side interior. Now let's look at angle 4 and angle 6. So angle 4 and angle 6. So where are they on the street? Well, angle 4 is on the left side of the street, and angle 6 is on the right side of the street. So they are on alternate sides of the street. You have to cross the street to get between them. And then we look at our two dark blue lines. They are both between line L and line M. So they are interior. All right, next let's look at angle 1 and angle 8. So here we have angle 1 and angle 8. So first, where are angle 1 and angle 8 in relation to the street? Well, they are both on the left side of the street. So they are on the same side of the street. Now we look at our dark blue lines for the walls of our house. They are both outside of those lines. So they are exterior. They're on the exterior of the house. All right, and finally we'll look at 1 and 7. So there's angle 1 again, and there's angle 7. So where are they on the street? Angle 1 is on the left side of the street, and angle 7 is on the right side of the street. So they are on alternate sides. And then angle 1 and angle 7 are also both outside of the walls of our house. So they are exterior. So remember, when you're naming them, first you name them by where they are on the transversal. Are they on the same side of the street or on opposite sides of the street? And then, where are they with respect to the two lines? Are they inside the house or outside the house? All right, here is a challenge. Let's look at angle 1 and angle 5. These angles don't fit the pattern. They are on the same side of the transversal, but one is on the inside and the other one is on the outside. This angle relationship is called corresponding angles. So here we have angle 1 and angle 5. If we look at our street, corresponding angles are on the same side of the street, but in this case, angle 1 is outside of the house, and angle 5 is inside of the house. They're called corresponding angles because they are in the corresponding position of their intersection. So they're both on the left side of the street and on top of their wall. When two lines that are cut by a transversal are parallel, and that's what these little arrows mean. If you see a pair of lines with the arrows on them, that means they're parallel. Our special angle relationships have special properties. So let's take a look at some of these angles. I know we always say, never trust the picture. In this case, I'm telling you it's okay to make assumptions based on the picture. So what do you notice about angle 1, angle 4, angle 5, and angle 8? They all look like they're the same. Now, how about angle 2 and angle 3, angle 6, and angle 7? They also look the same as each other, but still different from the other 4 angles. Now, what do we know for a fact is true about angle 1 and angle 2? They are a linear pair. So they are supplementary. And then angle 5 and angle 8, we know that they are vertical angles. And therefore, they are congruent. So, all of the angles, when we have two parallel lines cut by a transversal, they're all either congruent or supplementary to each other. So 5 is congruent to 8, 1, and 4. 5 is supplementary to 7, 6, 3, and 2. All right, so let's see what that means when we add numbers into it. So first we're being told the measure of angle 6 equals 75. Okay, so there's angle 6, and it is 75. We want to know what the measure of angle 3 is. Well, just looking at these, I can see that angle 6 and angle 3 are both acute angles. And so since I know that all of the angles either need to be supplementary or congruent, I know that the measure of angle 3 also equals 75. All right, let's just take it another step, make it a little bit more challenging. So the measure of angle 4 is 5x. And the measure of angle 6 is 45. And we want to know what is x. So let's take a look at angle 6 and angle 4. Angle 6 is acute, and angle 4 is obtuse. So since they all need to be either supplementary or congruent, they are supplementary. And supplementary means that they add up. 5x plus 45 equals 180. So we subtract 45 from both sides. So 5x equals 135. And then we divide both sides by 5. And x equals 27. Now let's just go back to the question and double check, what are we looking for? What is x? All right. So that is our answer. X equals 27. All right, our last one, and this is in your practice problems for today. If the measure of angle 2 is 3x plus 15, and angle 5 is 8x, what is the measure of angle 2? Well, so if we look at angle 2 and angle 5, angle 2 is acute, angle 5 is obtuse, so they are supplementary. So that means we add them together. 3x plus 15 plus 8x equals 180. We combine that 3x and that 8x. They're on the same side of the equal sign. So we just put them together. 8 plus 3 is 11x plus 15 equals 180. Now we subtract that 15 from both sides. And 11x equals 165. Divide both sides by 11, and x equals 15. All right, but now we stop. We look back at the question. What is it asking? What is the measure of angle 2? So now that we know what x is, we can substitute that in for the x in the measure of angle 2. So the measure of angle 2 equals 3 times 15 plus 15. 3 times 15 is 45, plus 15 is 60. So the measure of angle 2 equals 60. And that is it for our notes for today. You can go back and rewatch this. Pause it when you need to. And then go ahead and give today's assignment a try.